welcome back to Calculus Universalis. Today we're unlocking one of the most powerful tools in your calculus toolbox, the first derivative test, to find local maxima and minima of a function. We'll go over the strategy, learn how to use a sign chart, and practice with 3 AP-style examples. By the end of this video, you'll know how to find hills and valleys of any function like a pro. Let's get into it. A function has a relative or local maximum or minimum at a point if the graph changes direction there from increasing to decreasing. So a graph will be increasing, decrease, that is the maximum, decrease to increase, minimum. We use the first derivative test to figure this out by checking where the derivative changes sign. This will tell us if the function's increasing, if it's a positive sign, and then decreasing, negative, but it really tells us when that changes, so we can find the extrema. Step by step. Step 1, we need to find the derivative of a function f of x. Step 2, find critical points where f of x equals 0 or does not exist. Step 3, we need to make a sign chart. Test intervals between critical points, and then step 4, we need to interpret signs. If it's from positive to negative, you have a local maximum, negative, positive, you have a local minimum, and then no sign change, no extrema. Okay, now let's try this out. So our first example is going to be problem number 1. F of x equals x cubed minus 3x squared plus 2. We need to find and classify the critical points. First, take the derivative. F prime of x equals 3x squared minus 6x, which equals 3x, x minus 2. When you set this equal to 0, equals f prime of x. This is true when x equals 0 and 2. Now let's test the signs around those points. This is the derivative test. So we have 0, and we have a 2. This is for f prime of x. Let's plug in a negative 1. And then here we're going to plug in a 1. Here we'll plug in a 3. So if we plug in a negative 1 to this up here, what do we get? It's going to be negative 3 times negative 3, which is going to be positive. And then if we plug in a 1, it's going to be negative 1 times 1, which is going to be negative. And then if we plug in a 3, it's going to be positive. A 1 and a 1. So now we have our points of extrema as 0 and 2, and we can say that 0 equals a, goes from increasing to decreasing, maximum, 2 equals decrease to increase, minimum. And these are relative minimums. Now, example number 2. We have f prime of x equals x plus 1, x minus 3. Determine where f has a local maximum or minimum. Let's say we're going to set equal to 0. And then this gives us, this is true when x equals negative 1 and 3. Let's do this again. We have our chart, 1, 3. Plug in values in between. Go ahead and pause it. Give it a try. Okay. So I chose to plug in a 0, 1, and a 4. And in doing so, I got this to be positive. I got this to be negative. And then this to be positive. Sorry, this to be positive. which means we have extrema at each point. And then this gives us the knowledge that 1 equals a max and 3 equals a min. Now our last example is going to be similar. If you're given a graph of f of x, a prime of x, at what values of x does f have local maximum or minimum? Let's say this is a common multiple choice RFRQ setup. Look at the graph of f of x, where f prime of x crosses from above the axis to below. F prime changes from positive to negative, which is a local maximum. Where f prime of x crosses from below to above, f prime changes from negative to positive, local minimum. So if f of x crosses the x-axis at x equals 1 and x equals 4 going up, going down and up, there is a local, this is a local max and this is a local min. So here's your key takeaway for this video. F prime of x, positive to negative, max, when it equals negative to positive, min, and when there's no sign change, it is no extrema. So you can go ahead and try some problems on your own, such as finding and classifying relative extrema for f of x equals x to the 4th minus 4x squared. You can go ahead and try that on your own. You can find f of x as a graph, determine where it has extrema, and then answer this true or false question. If f prime of x equals 0 and does not change sign, is there a local max or min? In the next video, we'll dive into concavity and the second derivative test. Don't miss it, hit subscribe, and I'll see you there. Goodbye.